SPCC over lunch. This is the beginning of a short series of training videos that you can watch over lunch and kind of brush up on. In this case, SPCC. With this, we'll get right into it. My name is John Wigger, and I am with Cadenza Environmental, LLC, out of the Chicagoland area. So today we'll be talking about spill prevention, control, and countermeasures. So quick introduction, again, John Wigger. I've got about 30 years of environmental engineering, remediation, and compliance experience, mainly in the oil and gas industry. I recently retired from BP from an environmental compliance group role. I'm a professional engineer in Illinois, Oklahoma, and Missouri. Got a master's degree in civil and environmental engineering and a bachelor's degree in engineering as well. Got many years of experience, lots of soil and groundwater contamination transport experience, but the last number of years have been working very diligently to help keep refineries in compliance with environmental regulations, of which one of them is SPCC. Got a lot of background in NPDES, RCRA, B1, LDAR, QQQ, reporting requirements, engines, tanks, etc. Enough about me. So SPCC, we're going to talk about the applicability of it, how it's a performance-based regulatory requirement, what that means, reporting, and further resources. But I'll emphasize here that please always refer to SPCC rule and language and the official agency guidance, whatever that means these days. So SPCC comes from the authorities under the Clean Water Act, the oil pollution prevention regulations that were codified in 40 CFR Part 112. The original rule is effective way back in 1974. The point of it is that it's requiring facilities of a certain size, we'll get into that, to develop prevention, control, and countermeasure actions, as well as written plans that are designated or designed to prevent oil discharges from reaching the navigable waters of the U.S. We'll break that down along over lunch today. So SPCC plans are meant to address containment procedures to prevent an oil discharge. It also requires proactive control measures to keep oil discharge from entering navigable waters of the U.S. and adjoining shorelines. It also requires you to have effective countermeasures to contain, clean up, and mitigate any oil discharge that happens to do that. The other thing I want to emphasize here, and I mentioned it earlier, is that it's a performance-based rule, and that is the written plans essentially become written commitments of how you or your facility will comply with the rule. So it's not unlike a stormwater pollution prevention plan. That is, if you write it, make sure you are doing it and that you're following your own plan. Otherwise, arguably, you could be out of compliance with SPCC requirements because you're not doing what you said you were going to do. So the rule applies to non-transportation related facilities. So these regulations apply to drilling, producing, gathering, storing, processing, refining, transferring, distributing, using, consuming oil. And we'll get into that definition later. So examples of non-transportation related are the producing facilities, storage facilities, transfer facilities, such as we have photographed here. The main point I wanted to make here is that there are spill and rules for Department of Transportation, DOT related materials, transportation related versus storage and using activities. So if something is in transportation, and we won't get into the big definitions of that, but if it's in trucking or if it's in a train, pipeline, shipping, all of those facilities are covered under DOT regulations versus storing and using kinds of facilities, and that's where EPA comes in. There's some overlaps of that, and there was a memo of understanding between EPA and DOT that was written long ago that helps describe that. I'll give some references to that later. It's called, and but it kind of helps decide and helps you understand what the differences of those the applicability of those facilities are. So examples of transportation-related facilities, like I had mentioned there, trains, trucks, ships, even some pipeline facilities that are more or less wide spots in the pipeline. That's what you're looking up and upper left hand. They're not actually distributing that, they're just moving it. So what are the SPCC requirements? Well, if you have a facility that stores over 1,320 gallons of oil in aggregate in any above ground storage, or 42,000 gallons of completely buried oil storage, and it has a reasonable expectation of oil discharge to a waterway or adjoining shoreline, which basically means most every facility, there's only a few places in the US where that may not apply. The desert Southwest, for example, where if you spilled it, there's no way it could ever meet a water of the US, but those are few and far between. We'll get into that, a little bit of that in a moment. So the SPCC applicability is the owner and operator makes the initial decision on whether or not SPCC even applies or not. Again, it's up to the owner and operator to make that decision. There are no requirements to submit the SPCC plans to EPA for approval at a federal level. Some states do require it. For example, Washington does. EPA does not formally approve or disapprove of the SPCC plan. And the plan is required upon inspection during regular hours. So if it appears that you require one, that you must have it ready and upon inspection. There's a few nuances to that, but we'll get into that in a moment. So the SPCC applicability, things that are stored in anything, oil that's stored in 55 gallons or greater applies, but there are some things that could be stored that aren't counted. So for example, if you have oil that's stored in 5-gallon containers or even 30-gallon drums, that does not count against the 1320, nor does permanently closed tanks. And I can get into that a little bit, but just know that you could have a tank, and if you permanently close it under the right conditions, then it doesn't count towards that either. So the definition of oil. Oil is defined in Section 311 of the Clean Water Act, and it can be any kind, including but not limited to petroleum and non-petroleum based oils, crude oil, refined products from crude oil, animal fats, vegetable oils, even denatured alcohol, because it can create this sheen, and typically it's because there are oils in the denatured alcohol. So, navigable waters of the U.S. and the adjoining shoreline. Basically, applicability of SPCC is predicated on this reasonable threat to spill oil into waters of the U.S. Waters of the U.S., and I'm not going to go into the rabbit hole of what WOTUS is these days. The definition of that has been under dispute now for the past 3 or 4 years, and it's kind of all over the place depending on where your facility is located in regions and states and et cetera. But it's more or less safe to assume that most every facility probably does have some kind of reasonable threat to discharge oil to the water. There's a few places out west. And if you have questions about that, hit me up later with that. So examples of this would be streams and rivers and lakes and stormwater ditches, etc. Just some photos of that. Now, what is a facility? Look at this definition. It's huge. We're not going to get into it. I wanted you to know that it exists, and it is a very broad definition of what it means, and there's a lot to unpack here. But if you have questions about the applicability of a facility, we can chat about that later. But it's a very broad definition, and just know that there may be a few exceptions. So the key SPCC requirements, though, is to prepare a plan in accordance with good engineering practice. And there's no definition of that. Just know that. But it is up to a professional engineer to stamp it in most cases. So it also requires the full approval of management to implement the plan. That is, if you say you have a plan and it says, yeah, I got to call these response team, then the plan itself must say that, and then also ensure that the folks that are required to implement the plan have that authority, and it's clearly written into the plan. And also, anytime the SPCC plan is modified, then either for a recertification or a technical amendment or even an administrative amendment, any of those modifications need to be recorded in the record of revision, which is literally a piece of paper or electronic these days, in the plan itself, recognizing when amendments were made. So the SPCC requirements requires preparation and implementation in the written plans to address operating procedures for routine handling of products and materials and oil to prevent the discharge of oil, discharge or drainage control measures to prevent a discharge of oil, countermeasures to contain, clean up, and mitigate the oil, methods of disposal for recovered materials in case you did have a spill, and emergency contact list of phone numbers for response personnel that you may call in if needed, if it's a large situation, and the National Response Center. And I'll get into what the NRC is in a few. Plans, most of the time, at any of the larger facilities, do require the plan to be certified by a professional engineer. Again, in good engineering practices. The PE must be familiar with the rule. PE has to visit, or the agent has to actually visit the facility to inspect and understand it. Has to be in accordance with good engineering practices, as I said earlier. And has to consider applicable industry standards and in compliance with regulations. Inspection and testing procedures are established and written into the plan, and the plan is adequate for the facility. Again, the PE would make those determinations. So the plan also has to talk about the typical kinds of failure analysis that might happen. So where there's a reasonable experience indicates reasonable potential for equipment failure, tank loading and unloading equipment, transfer lines, corroded tanks, you name it. If there's some kind of experience that would indicate that these kinds of things could be potential and reasonable for equipment failure, then the plan needs to address that. And in most cases, that's true. These things happen. So it needs to be mentioned. And then in the cases where things like this may happen, the plan also has to describe and predict the type of failure that could occur, the amount of oil that could occur, the rate of flow and the total quantity of flow, and where it would potentially discharge to if this happened. So there have been amendments to the SPCC plan, but as you can imagine, this is a document that's created, and then facilities change and you use different products and you do differing things. So when facilities change and there is some kind of materially affect the potential for a discharge of oil, then a technical amendment needs to be made to the plan itself. So anything, and that's a broad definition, I understand, about materially affect potential for discharge. So commissioning and decommissioning of tanks, building and taking them down, replacement and reconstruction of tanks, piping systems, construction and demolition of certain things, changes in product services. Many things can change this. If that's the case, a technical amendment must be made to the plan within 6 months of the actual change. So you have a little bit of time to catch up once you make plan changes, but those also have to be certified by a PE as well. So also the plan has to be periodically reviewed. So every 5 years, if you don't make any technical amendments along the way, or a complete kind of reevaluation of the plan does need to occur every 5 years, and that needs to be recorded in the plan itself. It does not require a PE unless a technical amendment is made, but most larger facilities, technical amendments are usually necessary, as well as it's probably, if you have a large facility, say a refinery, for example, it's a good idea, certainly a best management practice, to have a PE come back in if it's been 5 years and take a look at everything. And I even recommend having a different PE look at it, because different from the one who had certified it earlier. If you're interested in doing that, that way you can get different perspectives of different opinions on how you're complying with it. So the key requirements are the facility must be, any facilities that are manned 4 hours per day or more, or the nearest field office is manned less than that. So the plan also requires you to have it on hand if it's more than 4 hours, if it's manned for more than 4 hours a day. If it's less than that, then it can be in the nearest field office. And a lot of these things were written before electronics. I would imagine there might be arguments to be made where you can keep this stuff electronically, or on a phone, or on a drive system, or something that is available to anybody at the facility. So inspections, tests, and records. SPCC requires you to conduct inspections and tests in accordance with the written procedures that you have developed by the facility or the engineer who certifies of the plan. In many cases, some of these procedures can be very large, so you can also use the plan to point to where these procedures exist. For example, at a larger refinery, those procedures can change periodically, but if your plan points to where those plans and procedures exist, I have seen that being used successfully, and even inspectors are okay with that. I'd say keep the written procedures and a record of the inspections and tests signed by the appropriate personnel. So again, you need, if you can't have it in the plan itself, at least make sure you have pointers to where all of this stuff exists for your facility. I wanted to point out, I'd said this is a performance-based rule. The rule also allows significant deviations from technical requirements of the rule when it is noted in the plan. So you can make changes, or you can kind of deviate from how you comply with a plan. But it is important that you call these out in the plan itself, what these written deviations are, and that the PE agrees with them. There are a few things that you cannot not or have an equivalent to. SPCC plans and the rules require certain training, certain record keeping, and administrative provisions, and you must comply with those parts of the provisions. So training. In general, anybody that is a trained oil handling personnel, and there are definitions of that, meaning operators, maintenance, prevention equipment, they must be trained to do their job, and you must have a record of the training that they've done their job, whether it's on-site training or in-field training or classes that they take, whatever it is, however you describe it, you must make sure that they have that training. Also, it must designate persons that are accountable for discharge prevention and who reports to the facility management. So the person that is responsible for the plan and or maybe the operations manager or something also has this accountability for discharge prevention. The SPCC plan itself must specify that. The plan also needs to schedule and conduct at least one oil handling briefing per year. So it's known discharges of failures that have happened over the year, malfunctioning components or new precautionary measures. All of that also needs to, this training needs to be done every year and recorded appropriately in the plan or pointing to it, and that has to be done at least once per year. I've seen this being satisfied with some computer-based training, for example, for a large facility, for operators, that kind of thing. So I'm going to get into what general secondary containment it requires. So general secondary containment will provide appropriate secondary containment and diversionary structures for all the operations of the facility, not the large storage tanks, but the operations, drums and totes and piping, all the kinds of things that happen, even equipment that is used. You must have general secondary containment, and I'll kind of explain what the difference is. General means you have these diversionary structures, ways to help keep it from going out, versus a sized secondary containment that has to hold, say, a large storage tank, dike system for that. So that the plan requires that. And the entire system must be capable of containing oil so that this discharge to the water cannot occur. Again, performance-based regulation. So as long as you have some kind of structures to prevent that, and oil doesn't get to the to water of the U.S., you're satisfying it. But as soon as you don't, and you have a spill or you have something that actually gets outside of general secondary containment and gets into the water of the U.S., you have failed. So understand the difference. So general secondary containment, one of the following preventative systems can usually be used: dikes and berms and retaining walls that are sufficiently impervious to the oil to keep it from moving, curbing and drip tanks, sumps, collection systems, culverts, etc. Even active, if it's a small one, maybe you're relying on active response. That's okay too. Just remember, if you fail, you fail. Excuse me, I had to get some coffee. Anyway, general secondary containment applies to the following examples: oil field equipment, transformers, manufacturing equipment, the actual processing units, that kind of thing. Transfer areas, piping runs, racks, manifolds, and truck loading and unloading. There, as I said earlier, there's no specific size volume requirements, and sizing is based on the typical spill size, not the container size. As I had mentioned earlier, you must predict what kind of spill might occur, the typical size of a spill that might occur in a situation like this, and it must be designed for that. So general versus size, specific size secondary containment. Specific minimum size requirements are required for bulk storage containers. Secondary containment must be sized to contain the largest single oil compartment or container plus sufficient freeboard to contain the precipitation. And I mention this because this is a big, usually, or can be a big part of some confusion. What does sufficient freeboard to contain precipitation mean? And that varies significantly from facility to facility and where you're located in the country. It's a lot of folks often cite 110% of the largest tank or 25-year, 24-hour storm event. I believe it's a best management practice to use the 25-year, 24-hour storm event because it is actually a number of inches of rain, which is equivalent to the number of inches of freeboard that you would need. If you use 110%, that isn't a number of inches. That's just a volume, and you can get that volume by making the containment very large, but not having very much freeboard. So we won't get into the specifics of that, but just know that it is an area of sometimes confusion and I guess dismay because people don't know exactly what they have to design it to. Leave it to, I guess, the professional engineer to help you make that decision in a facility. So some examples of size secondary containments: diking systems made of concrete or earthen, etc. I actually, in the bottom right-hand corner, have one where it's concrete, but there's a hole in it from a piping run. Just know that that makes it ineffective, and it could be called out if that was if you didn't plan on that. Some not great examples. Here's some places where there may have been secondary containment, but it's not very adequate, or it's filled with water, etc. Some other not great examples of containment where it doesn't look like it's adequate, can't tell for sure from the photo, and even the hoses that are outside, things like that. Another place where a loading area outside of it, just the line leaks themselves had caused some spill problems, as evidenced by this photo, what appears to be oil. So facility drainage. Drainage from dike storage areas should be designed to and restrained by the valves or other positive means. So if a dike system has it, you can't just leave it open. It either needs to be emptied by pumps or some other manual way to get rid of it. In impounded non-oily stormwater that drains offsite directly, so if you open a valve and it goes into a storm drain system that goes off the site directly, in those situations, that actually has to be you have to have a log of that, a log that you visually observe that there was no oil on it and that you let the oil go outside and leave the dike system into a storm drain, for example. However, in cases where that water may be collected by a wastewater treatment system, then you do not have to log that. That's something sometimes people don't understand about logging and not logging of that. So examples of this, here's dikes that are maintained closed. You can see the valves, they appear closed. The one on the upper right looks like, from photographic evidence, that maybe they've had some spill issues there in the past, and maybe just from draining a dike, not sure. Loading racks and size containment. Secondary containment is required for loading racks as well, and it must be sized for the volume of the single largest compartment of a tank truck that comes up to it. That's sometimes a point of confusion, and just know that that's in the rule, and read that carefully. If you, or ask me about it later. Loading area requirements. Loading areas versus racks are only required to have general containment, as I had mentioned earlier. And there are subtle differences between loading areas and loading racks, and just know that if that comes up. Oil-filled operational equipment must meet general secondary containment requirements. So equipment that is not a bulk storage container, but like hydraulic systems, lubricating systems, gearboxes, machine coolants, etc. All of that stuff has to have general secondary containment versus size secondary containment for storage. Secondary requirements of the facility is required to describe in the SPCC plan. Some other things that are required to be described are the security requirements. You must describe how you control access to oil handling and process storage areas. That could be fences and lights, I don't know, electrical shock system, whatever it is, but how you keep it secured from people that shouldn't be there. Also, how you secure master flow and drain valves. Sometimes see locking systems on those kinds of things. So only certain personnel can open certain drain valves. Also, what you've done to prevent unauthorized access to starter controls and oil pumps and all of that. A lot of that can just be whether they're in buildings, general security that you may have at a facility. Also, the security of out of service of unloading and loading connections of oil pipelines, how you secure all of that. The plan also requires you to address the appropriateness of security lighting for both to prevent acts of vandalism and to assist in the discovery of an oil discharge if you happen to have one. Inspections and integrity testing. It requires an owner-operator to consult and rely on industry standards to determine the appropriateness of the qualification for tank inspection personnel and stuff. So, long and short of it is you have to get good engineering standards, and it's you don't have to do this, but it's a good idea to reference a best management practice to reference known industry standards for systems like this. So American Petroleum Institute, for example, has something called API 653, which is a whole inspection and integrity program for tanks. And you could reference the fact that that is what your facility uses. Large refineries, that is typically the case. So you can reference the fact that you use that and that you have the appropriate inspection records and all of that goes along with using API 653. That's also true for smaller tanks, for example, where API doesn't address it. There's other standards called, one of them is a Steel Tank Institute has an inspection procedure that can be followed and is certainly appropriate to reference in the SPCC plan. So lastly, I mean, what do you do? These are all the things to prevent, but what happens if you actually have a spill? So spills of oil to water and adjoining shorelines must be immediately reported to the NRC, the National Response Center. Here's the telephone number. This also is required to be put in the plan itself. The reports, and when I said immediately, it's usually within 15 minutes of it actually occurring. That's kind of a best management practice and is more or less the expectation of EPA. They use the word immediately, but it isn't defined. Anyway, reporting of an oil discharges to navigable waters to the NRC. The federal government, the NRC is a centralized reporting system, reports it out to EPA and Coast Guard. Any person in charge of the vessel or onshore of the facility must immediately do this. The NRC relays this information to Coast Guard and an on-scene coordinator will evaluate the situation and make a determination of what other responses may be necessary. So there are a couple of other specific SPCC spill reporting requirements as well. So the first one was also just Clean Water Act, you need to do that, but this is specific to SPCC. And that is, if you have more than 1,000 gallons of oil spilled, you actually have to report if you have that, or 2 cases where 42 gallons or more of oil was discharged. That also has to be reported to the EPA regional administrator within 60 days. Likely that's going to happen anyway, or they'll know about it for other reasons potentially. But if they don't, just remember this is also a SPCC specific requirement. And lastly, just some other resources. API has an SPCC template called D16. It can be bought. It's a great template for a number of different oil and gas facilities, where you can take that template and fill it out. And it has a lot of hints of how to comply with all this. And basically, if you fill out that template completely, you'll have a pretty darn good SPCC plan. But you have to describe your particular plant and situation. So that's a really good reference. EPA also has a lot of oil spill and emergency response guidelines. As a matter of fact, pictured there in 2013, they used to have a different version of this. You want to know anything and everything about SPCC, it's in here. It's a tremendous guidance document, has examples, it has lots and lots of guidance and interpretations and all kinds of calculations and how to do things. It's a great reference. I use it all the time. There's also the what's called the SPCC Blue Book. You can look it up. Just look up SPCC Blue Book, and you'll find it online. It's goes over a lot of the same kind of material that I have just presented to you here. Some other materials, the SPCC webpage has, EPA's webpage has a lot of material that can be referenced, hotlines that can be called, lots of other materials. So with that, if you have any questions or comments or whatever, give me a call or email me. Click on the links above and around wherever they are. Hope you've enjoyed this lunchtime SPCC quick hit training. Thanks a lot.